This question talks about a ball being tossed into the air on the planet Katrinas. The height of the ball in meters above the ground, T seconds after be thrown is there. So that's the height. If necessary, da, da, da. Find the velocity and acceleration. Okay. So I think you know how to do that already, probably. So we know that if we have an AS function and we take the derivative S prime, that'll be velocity. And if we take the derivative again, S double prime, that'll be acceleration. So we'll do that. All right, so let's come up here. So here's the S function. Now we're gonna say, okay, what is S prime of t? Well, you take this power, a little bigger for us. Take this power and multiply it. It's going to go to the top. 2 times 13, 26 over 6, t to the first. You might wonder, why is it multiply the top? Because it's 2 over 1, right? A whole number 2 is 2 over 1 goes to the top. This 3, same thing, 3 over 1, it goes to the top. That'd be minus 15 over 6. Then you subtract 1 from the power, t squared. Just I subtracted 1 from that power, right? So there's the derivative. That's the velocity function. Now you can reduce that. You can divide top and bottom by 2, and this will be 13 over 3t. And this one, top and bottom by 3. It will be 5 over 2t squared. And that's what they get. And that, by the way, that is velocity. Okay, and then now let's take another derivative. Now, that's double prime, second derivative. So again, you take the power, move it down. 13 over 3. 1 times 13 is just 13. Subtract 1 from the power, so that's gone. Minus, and 2 here, 2 times 5 is 10 over 2. Subtract 1 from the power, t to the first. That's acceleration. And we can simplify that. This is just 5. 10 divided by 2 is just 5. There it is. So that's how we get the velocity and acceleration, first derivative, second derivative. Okay, now it asks us, over what interval of time is the ball moving in the position, in the positive upward direction? Upward. So when is the ball moving up? Well, the ball moves up when the velocity is greater than 0, positive. Oops, get scribbly there, positive. Does that make sense? Positive velocity means the ball's going up. Negative velocity means the ball's going down. So they're really asking us when they say, hey, we want the ball moving in the positive upward direction, we want the velocity to be positive. So then we take this velocity function right here, 13 thirds. Here, I'll keep it its original color. 13 over 3t minus 5 has t squared. You want that to be what? Greater than 0. Greater than 0. Huh. Well, that's tricky. How do we find out where that's greater than 0? Well, that's a good question. Well, what you need to do that's much easier said than done, is realize first off that thinking it out as we talk. Oh yeah, okay. You got to know what that is. That's an x squared function, t squared, x squared, whatever. And think about its graph. That's an x squared function. Anytime you have x squared, that's always a U shape. Up for, yeah, let me do it this way. If you have positive x squared, it's a U shape up. And if you have negative x squared, it's a U shape down. So you just kind of got to know that. You have to have done enough math and science to where when you see right here, this, you go, oh, this is a negative. I don't care what the number is, but it's a negative t squared. So if you put this on a t graph and you put the velocity is the y, right? Velocity is the y, because why is that? Because the velocity is out here like y, the y-axis, and the t is like the x. So it's just like y and x, it's velocity and time. So it's a velocity versus time graph. And if it's positive t squared or x squared, whatever, it's going to be a U shape up, and minus x squared is a U shape down. You just need to know that x squared graphs are always U shaped. So which one's this? This is a negative t squared. So we're looking at this one. So okay, so it's some kind of a U shape down like that. So what? Well, what are we looking for? We're looking for the part greater than zero, which would be this section of the graph. See, that's the part above zero, above a height of zero. So basically, if we can find these 2 points of intersection, then the part in the middle between them will be the part that's greater than zero. So I'm going to change to equal zero. I'm going to try to find the two places where the graph equals zero. How do you do it? Well, this one factor out of t. See how they both have t in common? See that trick? See, I'm not going to jump into the quad. You might say, Mr. You got to use the quadratic formula. Well, I could use, you totally could use the quadratic formula, and that would work. And this would be your A, and this would be your B, and your C is missing would be zero. So if you wanted, you could make this a decimal, be negative 2.5, and make this a decimal, which would be a 4.3333. And then this would be A, and this would be B, and C would be zero because there is no C. There's no term that doesn't have a T, right? Because normally there's a T squared, T, no T. The no T is missing, so C is zero. And then you could do the quadratic form, the negative B plus or minus square root of B squared minus 4AC all over 2A. And you could plug in the A is negative 2.5, the B is 4.33333, and the C is zero. And that would work. But this is way easier. So when you can factor, just do that instead. See how I took out a t? See how this is right? T times this will go back to 13 over 3t. T there will go back to t squared. Okay, so what? Well, now I can say the first t equals zero or the whole parenthesis equals zero. How, why? Why can I put two zeros when there was only one? Well, because it's logically, it's saying, see what it's saying? It's saying t all by itself times that big expression, 13 thirds minus 5 halves t, those multiplied equal zero. Well, remember what it means logically? If two things are timesing and it's equaling zero, that means either one could be zero to make that true, right? Is that sinking in? You really got to get that. If I said, hey guys, I'm thinking of two numbers, call them A and B. I times them and it's zero. What does that mean? How do you multiply two numbers or two things and it comes out zero? Well, the first one could be zero, zero times anything like zero times seven would be zero, or the second one could be zero, anything times like three times zero would be zero, right? If two things are timesing and it's equaling zero, that means the first one, so that means just the t alone could be zero and zero times anything would be zero. Or the second one, that whole big expression could be zero, and it wouldn't really matter what the first one is, and then the whole thing would equal zero, right? If two things are multiplying to equal zero, that means the first one could be zero or the second one. Either way, it'll make that true, won't it? Right? We're looking for what makes this true. What makes one thing times another equal zero? Well, if the first one is zero or if the second one is zero. So this one's already done right here. And that's one of our answers right there at zero. Remember, this is the t-axis. So right there at zero. I knew that already. That's why I put this dot there. The other one is you got to solve this equation for t. So I'm going to subtract 13 thirds from both sides here. I'm trying to solve for t. Bring this down. So this will be minus 5 halves t equals minus 13 thirds. Okay, what do you do now? You got to get t alone. So what's your last step? Multiply both sides by negative 2/5 because it'll cancel the twos, cancel the fives, the two negatives will become positive. Whatever you do to one side, got no choice. You got to do the same thing to the other. Here, nothing cancels, just two negatives make positive. 2 times 13 makes 26, 3 times 5 makes 15. 26 fifteenths. I guess they want you to divide that in your calculator. So just divide that. You're going to get the 1.7333, blah, blah, blah. So what does that mean? That's the answer right here, 1.7333. So that means this ball that they're throwing up into the air goes up, 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 and comes down after 1.7333 seconds. So when is the ball moving? Oh, I'm sorry. This is the velocity, not this isn't the position. I take that back. I was getting confused. This is the velocity. This means between 0 and 1.733 seconds, the ball is got positive velocity, means moving up. That means on a position graph, the ball's going up all that time for the whole first 1.73333 seconds. The ball is moving up because it's got positive velocity. Then right then at 1.7333 seconds, the ball stops and then begins to come back down. How do I know? Because right then it has zero velocity. So therefore, between 0 and 1.733, so there's the answer they gave. We put parentheses around those between 0 and 1.733. I guess they just want 3 decimals total like that. Parentheses. In all those that time, it's got positive velocity. Velocity is up there because that was a t-squared graph, negative t-squared graph. So it was upside down U-shape. Found the two places it equals 0. T is 0, and then T is 26 fifteenths or 1.7333. So, all right. And then last two parts. Okay. After initially being thrown in the air, when does the ball reach the ground? Hint, what is the ball's position when it reaches the ground? So part C, from over here, we're going to go back to the position equation. First one. Let's say, okay, there it is. Here it is here. It is 13.6 t squared minus, what was it? 5.6 t cubed. Okay. And they say, when when does the ball return to the ground? Well, it hits the ground. Hits the ground when S of t equals 0. Because remember, S of t is height. Didn't it say it up here? Yeah, the height of the ball is given by that equation. So this is really an H. This is really a height equation. See, it says right there. So when it hits the ground when the height equals 0. So that means you take the left side here and you make that 0. Okay. Now we got to solve that equation. So we're saying, when is the S, the height, 0? That'll be when the ball hits the ground. Well, how do you solve that equation? Well, again, I'm going to do what I did last time. I'm going to factor out t squared. That leaves 13.6 minus 5.6t. Is that making sense? Because t squared times that will be 13.6 t squared, and t squared times that will be 5.6 t cubed. Right? And then set each one equal to 0.7. Like this one, remember the same logic, two things are multiplying to equal 0. So how's that going to happen? The first one, the t squared alone equals 0, or the second one, 13.6 minus 5.6t equals 0. So this one's easy enough to square root it. T is 0. So that's just telling us the ball is at time 0, the ball's on the ground. Well, no big deal. This one now, this other one, let's subtract 13.6 from both sides. Boom. And so we get what? Minus 5.6t is minus 13.6. Now multiply both sides by minus 6 over 5. And 6 is cancel, 5 is cancel. Two negatives become positive. That gets t alone, doesn't it? But on the other side, two negatives make positive. These 6's just cancel. Just 13 over 5. Now they probably want a decimal. That's what is that? 2.6? Yeah, 2.6. So after 2.6 seconds, and there it is, after 2.6 seconds, we don't give them the zero because that's just when the ball started out, right? So we throw away that answer. The ball started on the ground, but after 2.6 seconds, it comes back down to the ground. And then the final question is right here. Um, what is the velocity of the ball when it returns to the ground? It's part D, I think. It's part D. Yeah, part D. Velocity when it hits the ground. Well, got to grab the velocity equation. So let's get it. The velocity equation. Let's go back up here. Where was that? This one right here. 13 thirds t minus 5 halves t squared. Did I get that right? 13 thirds t minus 5 halves t squared, right? Okay. It's a velocity equation. And we're saying when it hits the ground. When does it hit the ground? Well, we just learned that's at t is 2.6. So just plug in t is 2.6 because we know it's at 2.6 seconds when the ball hits the ground. And we want to know the velocity at that moment. Plug in 2.6 here, 2.6 there. Hit the buttons on your calculator. Go to Desmos and hit the buttons. Negative 5.633. Negative 5.633. Is that what they said? I'm just copying the answer from right here. Just hit the buttons on the calculator. And why is it negative? Because the ball's going downwards, obviously, when it hits the ground. So there we go.